Chapter Y Synopsis. Class 10. Subject Science. Chemical Reactions and Equations. A complete chemical equation represents the reactants, products and their physical states symbolically. A chemical equation is balanced so that the numbers of atoms of each type involved in a chemical reaction are the same on the reactant and product sides of the equation. Equations must always be balanced. In a combination reaction, two or more substances combine to form a new single substance. Decomposition reactions are opposite to. In a decomposition reaction, a single substance decomposes to give two or more substances. Reactions in which heat is given out along with the products are called exothermic reactions. Reactions in which energy is absorbed are known as endothermic reactions. When an element displaces another element from its compound, a displacement reaction occurs. Two different atoms or groups of atoms, ions, are exchanged in double displacement reactions. Precipitation reactions produce insoluble salts. Reactions also involve the gain or loss of oxygen or hydrogen by substances. Oxidation is the gain of oxygen or loss of hydrogen. Reduction is the loss of oxygen or gain of hydrogen. Acids, bases and salts. Acid-base indicators are dyes or mixtures of dyes which are used to indicate the presence of acids and bases. Acidic nature of a substance is due to the formation of H plus Aq ions in solution. Formation of OAq ions in solution is responsible for the basic nature of a substance. When an acid reacts with a metal, hydrogen gas is evolved and a corresponding salt is formed. When a base reacts with a metal, along with the evolution of hydrogen gas, a salt is formed which has a negative ion composed of the metal and oxygen. When an acid reacts with a metal carbonate or metal hydrogen carbonate, it gives the corresponding salt, carbon dioxide gas and water. Acidic and basic solutions in water conduct electricity because they produce hydrogen and hydroxide ions respectively. The strength of an acid or an alkali can be tested by using a scale called the pH scale, 0 to 14, which gives the measure of hydrogen ion concentration in a solution. A neutral solution has a pH of exactly 7, while an acidic solution has a pH less than 7 and a basic solution a pH more than 7. Living beings carry out their metabolic activities within an optimal pH range. Mixing concentrated acids or bases with water is a highly exothermic process. Acids and bases neutralize each other to form corresponding salts and water. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. Salts have various uses in everyday life and in industries. Metals and non-metals. Elements can be classified as metals and non-metals. Metals are lustrous, malleable, ductile and are good conductors of heat and electricity. They are solids at room temperature, except mercury, which is a liquid. Metals can form positive ions by losing electrons to non-metals. Metals combine with oxygen to form basic oxides. Aluminium oxide and zinc oxide show the properties of both basic as well as acidic oxides. These oxides are known as amphoteric oxides. Different metals have different reactivities with water and dilute acids. A list of common metals arranged in order of their decreasing reactivity is known as an activity series. Metals above hydrogen in the activity series can displace hydrogen from dilute acids. A more reactive metal displaces a less reactive metal from its salt solution. Metals occur in nature as free elements or in the form of their compounds. The extraction of metals from their ores and then refining them for use is known as metallurgy. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal. The surface of some metals, such as iron, is corroded when they are exposed to moist air for a long period of time. This phenomenon is known as corrosion. Non-metals have properties opposite to that of metals. They are neither malleable nor ductile. They are bad conductors of heat and electricity, except for graphite, which conducts electricity. Non-metals form negatively charged ions by gaining electrons when reacting with metals. Non-metals form oxides which are either acidic or neutral. Non-metals do not displace hydrogen from dilute acids. They react with hydrogen to form hydrides. Carbon and its compounds. Carbon is a versatile element that forms the basis for all living organisms and many of the things we use. This large variety of compounds is formed by carbon because of its tetravalency and the property of catenation that it exhibits. Covalent bonds are formed by the sharing of electrons between two atoms so that both can achieve a completely filled outermost shell. Carbon forms covalent bonds with itself and other elements such as hydrogen, oxygen, sulfur, nitrogen and chlorine. Carbon also forms compounds containing double and triple bonds between carbon atoms. These carbon chains may be in the form of straight chains, branch chains, or rings. The ability of carbon to form chains gives rise to a homologous series of compounds in which the same functional group is attached to carbon chains of different lengths. The functional groups such as alcohols, aldehydes, ketones, and carboxylic acids bestow characteristic properties to the carbon compounds that contain them. Carbon and its compounds are some of our major sources of fuels. Ethanol and ethanoic acid are carbon compounds of importance in our daily lives. The action of soaps and detergents is based on the presence of both hydrophobic and hydrophilic groups in the molecule, and this helps to emulsify the oily dirt and hence its removal. Periodic classification of elements. Elements are classified on the basis of similarities in their properties. Dobereiner grouped the elements into triads and Newlands gave the law of octaves. Mendeleev arranged the elements in increasing order of their atomic masses and according to their chemical properties. Mendeleev even predicted the existence of some yet to be discovered elements on the basis of gaps in his periodic table. Anomalies in arrangement of elements based on increasing atomic mass could be removed when the elements were arranged in order of increasing atomic number, a fundamental property of the element discovered by Moseley. Elements in the modern periodic table are arranged in 18 vertical columns called groups and 7 horizontal rows called periods. Elements thus arranged show periodicity of properties including atomic size, valency or combining capacity, and metallic and non-metallic character.